Hello, and welcome to Aggressive Physics. Today is day 99, and what I'd like to do today is discuss polarization. Now, polarization is the process by which we cause light to vibrate in only one plane. When light is traveling in a straight line towards you, it is a transverse wave. And although we often think of transverse waves as just moving up and down, they're traveling in 360 degrees around that direction that it's traveling. So although it's perpendicular, it's not just perpendicular up and down. We draw it as a sinusoidal wave because we usually draw it on a piece of paper or a blackboard or a whiteboard. However, it's actually traveling in three-dimensional space. So if you have a polarizing filter, you actually only allow the light to travel in one plane, so maybe just vertically. So then in that case, you're only allowing it to travel in one dimension. So it would be flat. What we can do is take that light and actually block it. If we took a filter and took one filter that might polarize the light vertically and another filter that polarized the light horizontally on top of each other, and actually block out all the light between the source and the observer. It's a method by which some office buildings have blinds. They could actually adjust the amount of light entering an office building by changing polarizing filters on the windows. Now, transverse waves are the only ones that can be polarized. Sound cannot be because it's a compression wave. And the way I can think about this, or a nice analogy, is a picket fence. If you think about a picket fence and we're sending waves through it, and I'm using a slinky to denote the waves, as I try to send a wave sideways through the picket fence, it's going to be blocked. If I send the wave vertically through the picket fence, only those vertical waves will travel through. Now think of light traveling through a polarized filter, which is just in one plane. Only the light vibrating up and down will be able to pass through a vertical filter. If it was a horizontal filter, only the light traveling horizontally. Now if I try to send a sound wave through the picket fence, it's just going to go right through because it's a compression wave, and the orientation of the pickets of the fence won't actually block any of the sound. So a picket fence is a good way to visualize it. Now there's two ways you can polarize light. One is by using a filter, and polarized filters are a series of lines on a piece of plastic typically that are all oriented together, so they're all parallel to one another. And you could have two different filters that could be rotated compared to one another. In fact, those of you who may have seen 3D movies in the movie theater or an IMAX theater, you've used polarizing filters as the glasses. And what they do is they send a polarized filter. Your glasses are set at two different directions, usually at a diagonal direction on both sides, and the light only hits your eye in the direction of the polarized filter. Well, what your brain does is it takes those two images and combines it and forms a three-dimensional image in front of you. So most three-dimensional films that you may see at an IMAX theater or maybe even Disney or something like that utilize the polarization. The other way that we can polarize light is by reflecting. And when light hits a flat surface and bounces off, it's only going to vibrate in the direction of the surface. For example, if light hits off the ground or water, it's going to vibrate only in a horizontal plane. And we call that vibrating light glare. So when you have glare, it's often annoying. It hurts your eyes. So what people will buy is polarized sunglasses. And if you have polarized sunglasses, they're typically going to be polarized in the vertical direction. That's blocking out glare. If you do that when you're trying to fish, you're going to actually be able to see into the water and possibly see where the fish are biting. If you do it when you're driving, or maybe you have polarized filters on your goggles for skiing, it's going to cut down on glare and you're going to be able to see better. It's going to give you a clearer view of the mountain or the road, and you're going to be able to drive without any glare. So polarized sunglasses allow us to avoid glare in general. So some of the applications, as I said, sunglasses are useful for polarizing. Make sure that they're vertical. If they're not, you'll just let glare in if you buy cheap ones that are horizontally polarized. You also use polarization when you go to 3D movies. Finally, if you do end up working in a high-end office building, you may have a situation where there are no actual blinds on the windows. Instead, they send an electric current to line up little pieces of metal inside the inside the glass, and that could actually cause a polarized filter. They'll have two different panes of windows, and they can adjust how they're situated. If we take a polarized filter and we put them perpendicular to one another, we could actually block out light. Depending upon how they're oriented, that will let different amounts of light into the room. So by changing the voltage, they could actually change how much light enters the room. So a high-end office building or maybe a high-end home could have electronic polarized windows that could act as blinds, and you can go from complete darkness to letting the light in completely. So polarization is a way that we force light to vibrate in only one plane. We can set up polarizing filters in two directions, perpendicular to one another, to block out light completely, or we can align them and allow light to pass through. Depending upon the angle between the two filters, we can adjust how much light actually passes through. When you go to the movies next time, check out the polarized light, the glasses you're given, and if you take the two glasses and you line them up with someone else's, you'll see, as you rotate the glasses, you'll see darkness and light. So the polarizing filters will actually be visible as you rotate two pairs of glasses over on top of each other. Make sure you don't break the glasses in half and do that. They typically frown upon that action. Otherwise, that's it for polarization. It's just forcing light to vibrate in a single plane. Thank you. All right. Well, as we discussed before, polarization is taking light that may be vibrating in all the different directions and allowing it to only vibrate in a single plane. So in this case, the light would only be vibrating up and down. Now, of course, when we send a beam of light, it's traveling in 360 degrees. So although it's a transverse wave like this, those are traveling all around the outside of the 360 degrees around the beam of light. So a polarizing filter will allow only, in this case, vertical light rays to travel. And if we were to then hit it through a horizontal filter, you'd have no light at all. So you can actually block out light using polarization. It also works by cutting down on glare, because what happens is when light, which is vibrating in all directions, hits a flat surface such as snow or a puddle on the ground like water, what'll happen is it'll come up and it'll only be polarized sideways, and that's what we see as glare. So what will happen is if we wear polarizing sunglasses, the glare will be eliminated. So we're going to want to cut out all that sideways light, which is the glare, and then it'll block out that. It's not going to block out all the light, it's just the unwanted pieces of light. Now what I have here are two polarizing filters. And this is the same glasses that you would wear at a 3D movie. And they use polarization so that each eye is receiving a different signal, and your brain puts them together and makes a 3D image out of it. What happens is if I were to hold this facing the camera and then oscillate the other one on top, you'll notice I could see through it there. And if I turn it 90 degrees, it's all black. You could see through it, all black. The way these work is if they're on top of each other, because I had them opposite, you could see through it. Each eye is a different direction. So if I put them inverted on top of each other, you'll see that the light is completely blocked out from the camera. The camera can't see through it. Now I could do the same thing with the laser. If I have the laser here and it's hitting the screen on the other side, if I shine it through and they're doing the same thing at the same time, we'll get an image. If I do the opposite lens, you'll see the beam is still here. If I shine it through the opposite lens, all the light's blocked off. So polarization can allow us to actually block the light from traveling. We can determine how much light actually gets through by turning this too. You'll notice that as I rotate it, we're getting dimmer and lighter as I change it. So we could actually create a situation where we could have as much darkness or as much light as is required. But the bottom line is, if we have the two lenses on top of each other in the same orientation, light will pass through. If we put them from the opposite, so right versus left, all the light is blocked off. And that's polarization. To check to see if you actually have polarized sunglasses, you could take another pair of polarized sunglasses and rotate them 90 degrees. If they don't block out all the light at 90, then you don't have polarized sunglasses. You got ripped off.